This next program involves the use of arrays in C, which is something that you'll have to do a lot of in the coming few weeks. And so you really need to know about how to write programs with arrays and make sure that you know how to debug them. So that's what this is all about. If you were to compile this program and run it, chances are you will get what looks like the right output. Despite that, there's a lot of things wrong with this program. So you want to take a look. You want to take a close look at this program. Make sure that you understand what it's doing. Okay, so it's not enough just to compile it, run it, and see if the output makes sense. Actually, there's quite a bit more that you have to do in this particular case. All right, so if you haven't looked at it, pause the video, take a look at this program, make sure you understand what it's doing, and we'll look at this next. So cat lec16-4.c, here it is, and then we can compile it, gcc -o lec16-4 lec16-4.c should compile. So this is this program has no compile errors, so it looks like maybe it's working. It turns out, and actually if you were to run this on most Linux systems, you will actually get what looks like the right answer, but there are serious problems with this program. Okay, so you might see a different answer. You might see the right answer, that is the sum from 1 to 10 is, and it should say the correct answer would be 55. So you can add that up. You can sum the numbers from 1 to 10, and I believe it should be 55. And you might actually see 55 if you were to run this on a Linux machine. I'm running it on a Mac OS X machine just to check, and sure enough, there are problems. So this is the same program, works differently on different machines. Why? Because it has some serious bugs. Okay, so you do want to take a close look at this. lec16-4.c. And here once again we use this a preprocessor directive #define to define size to be 10. And that's just like setting a const int to 10 and then setting up an array of size 10 essentially. If you're used to Java, you might think, well, you can't do that. Well, it turns out in C you can. In C you can set up an array like this. You cannot in Java. You can set up arrays differently in C as well. That would look more like what we do in Java, but this is valid C code. So this does work. So it does set up an array of 10 ints, and that part works. We initialize I and sum, so that works. You set up a loop, and here you want to think, well, look at this. Arrays, don't they start with index 0? Yes, they do. And we are using index 1 to begin and then only going up an index. So essentially we'll be doing indices 1 through 10 when we know that arrays of size 10 only have indices from 0 through 9. So there's a lot of things wrong with this. So we're not using index 0, we're using index 10, which is outside the bounds of the array, yet we saw the program run without errors. So unlike Java, C programs don't warn you when you go out of bounds of an array, and unlike Java. So in Java, as soon as you go out of bounds, you get a warning. You get an error message. Okay, so then we print out sum from 1 to 10. This is the 1 goes in here, the 10 goes here, and then we say we compute the sum after we set the components of this array AR. And then once we're done computing the sum, we print out the variable sum. So we can tell there's going to be some things wrong because we are accessing, in this case, you want to check and see if you access array elements 0 through 9. Those are the ones we should be accessing. It's not clear. That's what we will be doing. Okay. So one thing we can do, and let's try this out right now, is we can take part of this. I'm going to copy that. I'm going to paste it into Eclipse. Okay, so there's quite a few things that won't work, and of course there are different languages. So for example, what you want to do is you want to say int AR is equal to new int, and let's just put in the value 10 there. Okay, so this will work in Java. So you don't want to do this in your C program because it won't work. C doesn't allow you to do this, but Java does. So in Java, the thing is everything like arrays, objects are all, those kinds of things are all allocated. Memory for that is allocated on what's called the heap. And so whenever you see new, you're using this part of memory called the heap. In C, however, you have the option of allocating arrays on the heap or on the stack. This is a different part of memory. Stack is used to keep track of which methods or which functions call which other functions and so on. Okay, so what I'm going to do now is I'm going to say, in Java I get the two languages mixed up. Final int size is equal to 10. You can do the same thing if you want. Okay, that will work. And let me save this. Oh yeah, printf doesn't work in Java. So what I'll do is system.out.printf. That works. So of course, not everything is exactly the same. Okay, once I do that, once I change the printfs to system.out.printfs, then I don't get any compilers. And so what I'm going to do is run it. And then you might say, how come Java doesn't need to compile stuff? Well, actually it does need to compile stuff. It's just that in Eclipse, all of that, the compile procedure is sort of hidden from you. Okay. So if you were to take that C program that we were just looking at and try to run it in Java by making the appropriate changes. So for example, there is no pound defines in Java. So you have to use a final int, size is equal to 10 instead of the pound define. And instead of printfs, you have to use system.out.printf. Everything else is pretty much the same as Java, so it's valid Java syntax. The thing that you have to worry about is, sure enough, there is an array index out of bounds exception. Just as we thought, we were thinking that just looking at this loop, if the array is of size 10, you should only go between 0 and 9, including 0 and 9. But this loop is set up to go outside the bounds. Okay, so if you need to do this, if you're not sure about C, not sure enough that you want to go back and copy and paste it into Java, make the changes and check, see what happens there. Remember that once we fix these compiler errors, there were no other compilers with the rest of the code. The rest of the code did compile in Java. But it's only when we ran it that we got this out of bounds exception. surprising thing is if we were to compile and run this in C, with no compiler errors at all, but you get the program running. But as you saw, on some machines you can get the right answer, some machines you won't get the right answer. Okay, so I'm just going to pull up the code in C. I'm not going to change this. We ran this, we compiled it. So this is actually what Eclipse does behind the scenes. So as soon as you hit save in Eclipse, it actually runs the Java compiler in that case and does something similar. It produces bytecode in the case of Java. Here we produce an executable file which we can run. So they're very similar, they work the same way. But notice a big difference here on this Mac OS X machine. I just happened to get this completely wrong result. If you were to run this same program on 32-bit Linux, chances are it will actually work and give you probably the right answer too. But don't let that fool you. The program is broken and you need to fix it. So you want to look closely at things like this. Use the debugger and see if you are stepping outside the bounds of the array. If you were to look at it in Java, sure enough, you do see that it does step outside the bounds of the array. And so you want to convince yourself and use the debugger to do this. That is, step through it and see if you're going outside the bounds, and make sure that you can catch that. And you can sort of just see it right in the code, but at the same time, you also do want to be able to use the debugger. So how do you do that? Let's take a quick look. -G to use debug mode, gdb 16-4, and let's just try running it. Yep. So it runs and says program exited normally, but we know there is several things wrong with this program. Okay. So let's set a breakpoint at line 10, break 10, and run it. And we can, oops, L. So here we are at line 10, and what we want to do is display I and display a sub I. Oops. Array sub I. Okay. So let's step over this. And you can see as we step through this, we're setting the elements of this array AR to whatever value I is. And you can do N, N, N. So, okay, so here is what we see. We went from I equals 9, which is fine, and we set AR sub 9 to 9. But then notice AR sub 10, we're setting to 10 outside the bounds of the array. So definitely we are going outside the bounds, and so we need to fix that. So don't worry about this. This is fine. We bump up I beyond the bounds, even beyond 10, and we see some strange value there. That's no big deal. That's the fact that you can even index beyond the bounds of the array should be worrisome, but this by itself, this value is not something we have to worry about. So take a look at the rest of the program and make sure that you can understand what it's doing. Make sure that you can step through the debugger and fix all the errors.